This tutorial covers how to do basic computer-aided manufacturing in NX9. I'm going to go through a step-by-step process on how to do a CNC milling operation for this link. So this is a link that's been used in a previous tutorial. It's pretty simple geometry, but we can still go through some interesting machining operations on it that are applicable to much more complicated parts. So within NX9 we need to open so go to File and the manufacturing tutorial or manufacturing module. So I'm going to click manufacturing. So it's going to open this new screen. Note that now I have the operation navigator open. I have an NC numeric control program blank here, and I need to get started working. So what I'm going to do first, so if you'll note kind of the workflow up here, I have tools, geometry, operation. I'm primarily going to be using the tools and operations today. Since we basically have their 3D geometry, we really don't have to use this at this time. So the basic process of machining this, I'm working under the assumption that I'm making this out of actually a block of some kind of stock. I'll show how to model that and do the in-process machining in a later tutorial. For now, I'm just going to cover the basics without actually using the blank material. I'm assuming that when you're actually making this part, you know what the blank looks like, and you're taking that into consideration when you're actually machining this part. So the first operation that I'm going to cover is how to do a face milling operation to mill this top face. So in order to do that, I'm just going to use an end mill. This is only an inch across, so I can use a 1-inch end mill, say, and I'm going to have a little bit of step over on it. If I wanted the best surface finish I could realistically get in a mill, I'd probably use a fly mill or a face mill that's wider than the surface itself. But I'll start with just a regular end mill tool. So I need to create that tool, so I'm going to come up here to Create Tool. Note I get this new dialog up here. So if you open the type, you see all the different kinds of operations that NX can do. It can actually do, almost anything when it comes to CAM. We're going to stick with mostly mill planer, and then we're going to do some hole making and use drill later on in this tutorial. But you can see all the crazy things we can do here. Multi-blade, so if you want to make a turbine blade, there you go. You need a nice 5-axis mill to do it though. Mill planer is what we're going to stick with though for now. I'll let you experiment with those other things later. So there's some libraries here. Most of the time you're not going to have anything in your library, so we're going to create tools from scratch. You can see there's just little pictograms for each of the different tools that kind of lets you select them based on what they look like. I'm going to create just a regular milling tool. That's the most applicable from all the ones in here. Note that it just creates a generic machine. I'll cover again this kind of stuff in a later tutorial. For now, we just keep it for the generic machine though. This works perfectly fine for a 3-axis machining, 3-axis vertical machine center. So you can see down here, by the way, this XM, YM, ZM, those correspond to the X, Y, and Z coordinates for the mill. So this would be the X, which is generally the left, right. This would be the YM, which looking at the machine, that would be into and out of the machine, and then Z is the up and down axis of the machine, which is pretty standard for a 3-axis mill. So that lines up originally with the axis of our part. So if I want to change that, I can either change the rotation of the part, or I can change the machine's coordinate system, which I'll do in a later tutorial. For now, just bring your part in with the coordinate system, your X, Y, and Z aligned how you'd align it in the mill, and you'll be okay. So I'm going to go ahead and since I've got the tool, generic machine, here's where I name the tool. So if I need to use some kind of description other than just mill, otherwise it's going to get confusing really quickly. So I'm going to call this mill just 1 for now. If you start using special characters and spaces, NX starts complaining, so keep these descriptions simple. And so I'll hit OK. Oh, I've already created that tool. So I created that in a previous tutorial, or a previous my test run through this tutorial. So I would retrieve that tool from the library, but that's not going to help you all. So let me name this just something a little bit different. So mill 1-inch, okay. So this is where you get to enter all the parameters. So you can see lots of stuff to enter here. Diameter is the main one that you're interested in. It's already defaults to 1. You can enter the radii, taper angle, tip length, all these things in there, the number of flutes, lots of material. You can define the material for the mill itself if you're using the automatic feeds and speed calculations. For now, we're not going to do that though, but it's pretty easy to set up. You can also see up here shank and holder. You can define this if you're worried about crashing that into something. You can actually model those things as well. It's not required for this basic machining, but it's pretty easy to do. What I do need to set is the tool number. So when I actually set the machine up, I'm going to have tools in the different tool stations, and I'm going to have offsets in the machine, things like the vertical height offset and the cut comp, which I generally don't need cut comp when I'm machining this way, but I'm going to go ahead and set all of these to 1. So whenever I load this actual tool into the machine, it's going to be at station 1. You can see some of the offsets and other things here, which we don't need to change for now. So that looks good for what I need to do. I'm going to go ahead and hit OK, and I've got an end mill. So let's do something with it. So I'm going to go create operation, and this is going to be a planar milling operation, and I want to do a facing. So I'm going to look through here, and that's face milling with boundaries. I've got manual face milling. Let's do face milling with boundaries. I'm going to use in this program, I need to pick a mill, so I'm going to pick that one I just created, which is the mill 1-inch. Geometry, don't change this unless you know what you're doing. You want to keep that to MCS mill for now. Method, it's very tempting to pick one of these right now. Just leave it at method and then select what you want to do later. And then you need to name the operation. So I'm going to just name it that because I think I already have one named face milling somewhere, so I'm just going to hit OK. And here's where you do the interesting stuff. So note I have that geometry set up here. I don't need to change that, but what I do need to do is pick the part that I'm machining first. So click this little icon, pick your part, click OK. Now I need to set a boundary that I want to mill within. So to specify face boundaries, I click that. Click the top face, that's where I want to mill and make it nice and flat. This is a very important step here. You'll note these little arrows, these little hash marks going around it. I've got tool side. I want the tool to be inside this plane. I don't want to machine outside of it, I want to machine inside of it. So that got it correct this time, sometimes it doesn't. The rest of it you can ignore for now. I'm just going to click OK. What I need to do next, so check body, so if I have something like a clamp, and you can see that the icon there is actually like a little Tico clamp. If I need to avoid a clamp, I can actually model a clamp and then specify that as something that I should avoid with the machine. That's fairly advanced. I'm not going to cover it in this tutorial, but that's something you can do, certainly. And that should be everything I need. So if you'll see a tool down here, it's already got that mill 1-inch since I already selected it. Tool axis, I generally don't need to select. Sometimes, since we're doing 3-axis milling here, I've had NX not do the right axis. It's done it right when I've done this tutorial before, but I'm going to be using the Z machine axis, so I can pick that as well. So let's just try that, because I think it's the safest thing in general. So I'm going to do plus ZM axis, so it's going to use the tool on the plus ZM axis, which is where the tool would be in a 3-axis type machine. So method, here I can select between a finish, rough, or a semi-finish. I'm going to go at semi-finish because I basically don't want to run a finishing pass with this. I just want the last pass to do the job, and that works alright in face milling. Note that for cut pattern I can pick all sorts of crazy things. Zig, if you want to do climb milling the entire way, which you generally want to do, you can do that. Zigzag's faster because you don't have the time to pick the end mill up and move it back to the start. You can profile, you can do a trochoidal if you want to. We don't generally need to do trochoidal. I mean, you really know it. Generally, if you need trochoidal, you know why you need to do trochoidal, so I won't cover it. Let's just do a zig real quick. Percent step over, so that's from the tool flat, is how it's measured. So what this means is, since I'm using a 1-inch cutter, it's going to take 3/4 inch cuts basically, and there'll be a 1/4 inch of overlap. Blank distance, I can leave that 0.1 for now. Depth of cut, final floor stock. So blank distances basically says that the blank extends a tenth of an inch above it, and I should probably cover that. So what that means is if my actual blank is higher than this, the machine might wrap it into it, which causes a crash, which causes stuff to break. So I want to make sure this value is greater than what the distance from where my plane I need to machine is to what the plane of the actual piece of material I'm machining. So it is quite important to get right. For now, let's just assume that 0.1's okay. Final floor stock is how much stock I want to leave on it, so I can set that to be 10 thousandths and do a slower finish pass. In this case, I'm just going to leave it to be 0. And then you can see all the menus here for all the cutting parameters, which there's just tons and tons and tons of parameters. And this is why you really kind of need to know a little bit about machining before you even start trying to do CNC machining. But for those of you that have had some machining background, you can kind of dig through those menus and see all the crazy things you can set. At a minimum, though, I need feeds and speeds, so I'm going to click that button. I want to do this manually, so I'm going to click Spindle Speed, and I need to select speed for this. So let's do 800 RPM. How you would actually get this value, rather than just kind of pulling it out of thin air, you would actually use a machinist manual based on the material, the kind of cutter you have, and you can actually calculate that based on surface feed. So NX has the ability to automatically do that. You just have to set lots of properties in order to be able to use the little lightning bolt up here for it to do that to you. Generally, I like to use machining tables and then just use my experience to increase it or decrease it as necessary. But you can always manually set it. Feed rate, so this is 10 inches per minute, and that sounds fine. I'm just going to click OK. And now generate, and I've got tool paths. And so this is Zig. So you'll note that it plunges in, comes over here, picks up, rapids over here, plunges. And you might think it's kind of strange. It should just do it in 2 passes. Zig is going to be oriented so that the actual machining cuts are in the X direction. Note my parts primarily align with the Y direction. So what I could do is rotate my parts so that this would be the X direction, or I could rotate my machining coordinates. So if I actually wanted to correct that, I'd have to rotate that. I just wanted to do it this way so you could see how if you don't have it rotated correctly, you could get something that you don't really expect. And you could see, if I switch to zigzag, you can see how the tool paths change. That's a lot more efficient method, but sometimes you're climb milling and sometimes you're not. So it just depends on what you're doing, what surface finish you need, and things like that an experienced machinist would know. So Zig works if you got the time for it. It's not the most time efficient. So generally, if you're going to rough a lot of material, you'd probably zigzag. If you're going crazy fast, you'd probably use a trochoidal. But let's just stick with the zig for now. Okay, and so that's our first tooling operation. If I want to verify that, I can click that button and I can get a playback. Just one thing to note, NX, if I leave it on the default 10 speed, things happen so fast you can't see them on any modern computer. So set that thing back to 2. Make sure you rewind and then press play, and even then it's just like lightning speed. So they haven't scaled this for modern processors, so they kind of need to do that because it runs too quick. But you can at least get some preview. You have to rewind it though. Step through them again. That's just ridiculously fast. But anyway, so it looks good. I'm going to click OK. And then OK, and you see I've got my first operation here. So what I want to do now is I want to start getting these holes made. So I need to spot drill these or do center drill these holes first. If I don't do that, whenever I try to plunge an drill bit spinning into this thing, it's not going to pick the center of the hole. And worst case scenario or best case scenario, the hole is a little off center and might have a little bit of a slope to it. Worst case scenario is the drill bit breaks. So I need a spot drill. So to do a spot drill operation, I need to create a tool. So I'm going to create a tool. Note there's no drill bits here. So to create a drill bit, I need to go under type to, I can do hole making or drill. Hole making is a little bit nicer for whatever reason. I don't know why there's 2 of them, but I like the hole making options better. So for just doing things like spot drills. So you can see all the options. I wanted to use a center drill though. So center drill, let's do a 1/4 inch center drill. Okay, so I need to set the diameter to 1/4 inch. Tip is 1/8. 2 flute. high-speed steel. That looks good. You can see buried somewhere in there. That's what the tool looks like. There we go. I'm going to click OK. I've got that center drill. I want to go ahead while I'm creating tools and create a 1/2" drill bit. So create tool. I can do in the same still in Holemaking. Let's get a drill bit, standard drill bit, 0.5, 0.5. 0.5. I can set point angle. This matters for the depth that you drill through. If you have a smaller angle here, you need to drill through more to make sure you get all the way through the hole without any kind of taper. Flutes and all the other properties, of course, you can change as well. You actually do need to set flute length correctly based on whatever drill bit you're using, because if you drill down past the flutes, bad things can happen. So I'm going to click OK, though. I don't need to change that for now. Oh, actually, I want to go back and change that tool real quick. Sorry about that. I had to pause it for a second. To edit a tool, so note you see these little icons here: program order, machine tool, geometry, machining method. Those change what shows up in the operation navigator down here. So it's really kind of frustrating to find where you edit tools. What you do is click on the machine tool view, and then here in the operation navigator you get all your tools that you can edit. So what I need to edit is I need to go back to this standard drill 0.05. If I drill this hole, so if I want this to be a 1/2", more or less, within a thousandth or so, I can't just take a 1/2" drill bit to it, because it's good. 99 times out of 100, it's going to be a thousandth or two bigger than that, and sometimes even more. So, especially if I'm just trying to take this thing in one shot with a 1/2" drill, which I can do. There's nothing wrong with doing that when you're CNC machining, as long as it's nice and sharp. But it's probably not going to be exactly 1/2 inch. Or close enough for whatever I'm working with. So I want to come back and use a smaller drill bit. I can actually change the name of this right here. At least I haven't had experience trying to do that before. But so what I want to do, though, is I just want to go ahead and change the diameter just to something under a 1/2 inch. So let's do 10 to 15 thousandths is what I want to leave. So I'd have to look at a drill chart and see what the next smallest size is. But I'm just going to do call it 485. There's probably something somewhere around that. But again, I'd have to get a drill chart to figure out the exact size, but that's 15 thousandths under, so it'll work. So it'll make sense while I'm doing that here in a second, but at least that covers how you edit tools if you get stuck in with something that you need to change. So I bet I can change the name there. Yeah, I can. So let me rename this guy 0.485. Okay, so now it's all good. Okay, so now I want to use that slightly under 1/2" hole to drill both of these. So actually I want to do the center drill first and then use that. So what I need to do is create an operation. I'm under Holemaking. Now that I have got, go to Holemaking. I want to do spot drill. I want to keep it in the program. I don't want to use a 1" mill to spot drill. That would be funny. Let's do the center drill, the one I just created, the center drill 0.025, MCS mill, method, spot drilling 1. Okay. So what I need to do is pick the hole, basically. So specify hole or boss. I click that icon. Centered hole, which is what I want for almost everything, but you can see some of the options here. And then what I need to do is pick the face of the hole will work. If you right click and go to the filters, you can see all the different things you can pick. So I want to do the face of that hole, and then I want to do the face of that hole, and it's got both of those in there. I hit OK. And note here, before I hit OK, optimization. So if you're doing something with like 20 holes in it, you can actually optimize to do the fastest order for machining those, something more of in a manufacturing environment. But since there's only 2, it's obviously that's not an issue. And I've got those 2 things in there. So I can pick method. It doesn't really matter that much in this case. If you set it to drill method, there's really not that big difference between finishing and roughing with that. Feeds and speeds I need to pick, though. So let's set spindle speed, call it 600. Percent retract speed I don't need to set unless I care about it. Inch per minute's probably a little fast. Let's set it to 4. Hit OK, and then that should be pretty much what I need. Hit generate, and there we go. So just like with the previous one, I can verify, click verify, set the speed to 2, rewind, play, and it's going to happen at light speed. But it shows the center drilling operation. So now I've got them nice and center drilled. What I want to do now, I'm going to click OK, is actually drill the holes. So in order to do that, I'm going to go to create operation, hole making. Instead of spot drilling, I want drilling. I want to set it to that 0.485 drill. Okay. I want to pick holes, same 2. Note that its depth limit is going to go through, and it's going to use the tip angle of the bit to calculate how far it should go through. Just make sure you don't have anything under there that you don't want drilled, because it's going to have to drill through a little bit to get there. Okay. Feeds and speeds. Generate. We've got tool paths, and note that it goes quite a bit through. So if you've got your nice $500 Kurt vise underneath this, you're going to get a couple holes in it, unless you put some kind of a spacer or have this thing up on parallels. So, but it's fine for what we're doing. Again, I can generate and verify, so set it to 2, rewind it, play. Again, it happens super fast, but you can see the path outlined for it. So now I've got my holes rough drilled. To finish them, I need to ream them. So I need to create a reamer. So what I want to do is, before I go too much further, I want to go ahead and set this back to program order view, just so I can kind of see how my program's evolving here. I want to create a tool. Still under Holemaking, there's Reamer. Reamer 0.5. Okay. I want to set the reamer to 0.5. Everything else is okay for now. I kind of skipped setting tool numbers. I'd have to go back and edit the tools to add those. So this would be after the center drill, after the 0.485. This would be tool 4. Okay. And now I need to create the operation. Holemaking. Note that, so this is one oddity I haven't quite got figured out, is that there's not a reaming operation under Holemaking. So you actually have to go to drill, and then you'll find reaming right there. I want to make sure I pick the reamer, so 0.5. Method, MCS mill, that's all fine. Okay. So this is a little bit different dialogue than the one for Holemaking, so it's good to learn how to go through this dialogue. So I want to specify the holes, and it's this completely different crazy menu that took me forever to figure out what was going on with. So what you want to do is click select, and then you get another crazy menu. So you want to do the edge of this hole and the edge of this hole, and then click OK. And note you'll get a little asterisk 1, asterisk 2. That's the order. You can use this to optimize the order for lots of them, and you've got lots of other things you can change here if you want to. But the bare bones you just need to do is select the points and then optimize. So, okay. Now this is just the point in the XY plane. I need the top and bottom to drill in this dialog. In this case, ream. So I want to do top surface. I want to pick up the face, that face. Okay. And then I want to pick a bottom surface, face, that face. Okay. And now I want to go down and set this to be standard drill will work for this. That way I don't have to use any special G codes in the machine. I can just use a drill cycle, which almost all machines use basically the same setup for. Through hole clearance, I want to make sure this is how far past it goes. The reamers, most of the ones I'm familiar with, they have a chamfer on the bottom, and so you want to make sure it goes through far enough to get past that chamfer. Otherwise, you're going to have step in the hole. And then there's your blind hole stock as well for avoiding rapiding into the surface of the stock. I don't really have to do this because it was already face milled, so I can set this to be a small number. I still want it some number though, just so it's above the surface a bit. It just doesn't rapid down right to the surface. That's something that gives you a heart attack whenever you're machining. Is something that rapids right down to the surface height, and it's sometimes you actually stop the machine because you think it's going to crash. So I want a little bit of breathing room above the material. I can set feeds and speeds. So reamer, again, I'd have to look this up on a calculator, but reamers are pretty slow. This is called 400, and then I want to do 2. Okay, and generate, and I've got my holes reamed. Okay, so now just an update of where we're at. I've got this thing flat. I've got it spot drilled, I've got it rough drilled, I've got those holes reamed. I'm about ready to cut this thing out. So in order to do that, I'm going to do something called a profile operation. So I need to create an end mill for doing that. I've got that big 1-inch, but the problem with using a big 1-inch end mill to do that is I'm losing a lot of my stock material to do that, and I need lots of clearance. So let's do a smaller end mill. Let's do like a 1/2-inch end mill. So create tool, mill planer, mill 0.5. Okay, I've already used that one. 0.5 inch. It's okay. I want to set this to 0.5 diameter. I can set these other things as necessary. This is going to be tool 5. Okay. Now I want to create the operation. I'm in mill planer. I want to do, so going through here, I want planer mill, that's profile, planer profile, that's what I want. I don't want to profile with a reamer, I'd break the reamer. I want to do mill 0.5 inch, method MCS mill, planer profile. Okay. Just like with the face milling, I need a part boundary, so I'm going to click that. I'm going to use the face. I could do edges. So I actually don't even have to have 3D geometry to do milling. All I need is a top plane, a bottom plane, and some curves. So this is useful for like machining text. You don't need to actually draw what the text would look like machined. You basically just need the line drawing for the letters, which NX can do, and then you just pick all those curves and NX will mill those. So, but I do have a face, so I'm going to do face. I'm going to pick that face. Note, I do have to get this right, otherwise NX complains and it's kind of hard to track down. So I want to make sure material is on the inside. You can see the little hash marks, so that looks good. I have no idea what Tonto means, by the way, so ignore Tonto. I'm going to click OK. And I do need to set, so I've got part boundaries, blanks. I don't have a blank that I'm worrying about right now. I'm not worried about any clamps. About trimming, I'm not worried about. Okay, floor I do need to set. So specify floor, bottom's the floor. Okay, now here's where you probably need to do something different. So if I leave it at 0 inches, so whenever you machine a part like this, if I'm actually trying to cut it out of the blank that I'm machining, if I cut through to the bottom side of the blank and then machine around this, as soon as the machine gets through cutting, this part's going to be free from the whatever's clamped down, and it's going to go flying, or it's going to bind up and break your bit, or it's going to bind up and damage your part. So what I generally do is I can leave it a little short and then take this whole thing out, bandsaw it out later, and then clean it up. Or I could leave a little bit of thickness on the bottom. If I want the best surface finish, I could leave. I could actually machine down past the surface a bit, but I'd have to have a thicker stock to do that, and then I'd have to take the finished part out, stick it back in a machine, and then face mill it flat if I wanted it to be nice. So let's just assume I just want something. Basically, I just want to get it done. So I'm going to go ahead and instead of cutting it at the final depth or cutting it past, I'm going to assume that I'm working with stock that's just somewhere around 1/2 inch, maybe a little thicker up top and bottom. And so what I'm going to do is actually pull this up a little bit above the surface. Oh, I did point nose. That's the one I want. Yeah, 1/16 of an inch, and that way there's a little flap there that's super easy to bandsaw. And I'll get it nice and finished down to that point, and then I'll just have to cut that out and figure out how I'm going to deal with the flashing later. So if I want to cut deeper, let's just make it a positive sign. I can cut it deeper, and it mills it nice all the way around, but I'd have to have a little extra stock here for something to hold on to, and then I'm going to have to do a facing operation on this side. So a lot which way depends on what you're machining and how you want to finish it. Since I'm going to do a finishing operation all the way around it, let's go ahead and just leave it on the long side and assume you've got some extra stock down here. So I want to machine past it. Let's go past it that 16th. Hit OK. And that's where it's going to machine down to. Method, I'm going to do roughing first. So rough, part stock. This is, if I hover over this, it shows you what that means. This is how much it's going to leave. 30 thousandths is a little bit big. Let's leave 15 thousandths on it. That will take care of that. The finishing pass. 8 inches, I could do that, but let's just do 8. That's the speed, cut depth, constant. So let me go ahead and show you what this looks like. So I'm generating that. If you did that with a 1/2 inch end mill, it depends on if your settings are set up right and you know what you're doing, you could do that no problem. Generally you're going to step this though, especially if you're in a machine where you can't use coolant, so or you're doing something high strength. So generally I'm going to use different levels of cutting. So you can easily set that. So note here it's got cut depth constant. You want to set that to, let's see, we want to use, oh yeah, it's constant will work. You can see the other options, floor only, floor then critical depths. We want to do constant, but we actually want to set the constant. That's what I want to change. So let's do just 1/8 inch cuts for now. And you can see it breaks it up into 1/8, 1/8, 1/8, and then whatever we need to get through the bottom of this thing. You can see the kind of entry it uses. It comes down away from the part and then it comes in on a quarter circle. It does that because if you plunge down right at this point with this end mill, it's going to grab basically into the surface and kind of mar it right here. So if you want the best surface finish, you need to kind of come in out here and then go around it. That way you come in tangent to it and you don't mar the surface right there. There's a few other options. You can get those under non-cutting moves. You can change the engage, which you can see all the different options here. Lots of different cool things to do. But you also have to have space here. If this is where your nice Kurt vise is, your nice Kurt vise is going to be machined, which is probably not going to end well with if you use a 1/2 inch high-speed steel bit to machine a Kurt vise. That'd be interesting to watch, but I don't want to see it. So make sure you've got clearance over here. So that looks good. I've got tool paths. Okay, so now I've got 15 thousandths on the outside of this that I need to clean up. So I need to create another operation. Mill planer, same setup, same end mill. Okay, I want to part boundary, same part boundary, material inside, floor, 0.0625, just like we had last time. I want to finish. I want to do one pass, take that 15 thousandths off, make sure part stock is 0, so you actually take that off to whatever the 3D drawing says instead of leaving a little extra on there, and I've got that. And that should be my part. So I've got face mill, spot drill, rough drill, ream, profile, roughing, finish, and I'm ready to take this thing out of the CNC mill. When that's done, cut off the whatever's connecting it to the stock, flip this thing back over, stick it back in the mill. I can run this facing operation again if I want to, and I can run this without the rest of the program. I can set that up in the mill, or I can process this one separately. So what I have now is I have sort of intermediate tool paths. These aren't things that I could actually run a machine. So what I need to do now is actually get these things to a point where they could be in a machine. So I'm going to select all of these things, and then I want to post process. Here is where I want to pick which machine I'm using, mill 3-axis. These need to be customized for whatever machine you're working on. That's something that's fairly sophisticated. I might get that in a later tutorial. It's pretty, you pretty well have to know CNC machining pretty well to even understand what's going on in that, and have a machine that you're very familiar with the G-codes required for it. Mill 3-axis, it's very rare for this to actually work on a 3-axis mill without tinkering. So, but we're going to use it for now just so we get some G-code. Output file, this is where it's going to save it. So desktop NX motion link. I don't know what this PTP is. Let's just call it NC. So under this directory, desktop NX motion link. Okay, and then OK. I do that, and I get this stuff, which is G-code. So you can see the G-codes set the machine up, a little header up here, and then you can see all the different motions. Then let's find a tool change. There's a tool change. MO6 is a tool change. Note the 00. I need to actually go back to the tool menu and change these offsets and then repost this thing in order to get these things correct, because tool 0 doesn't exist in the machine, and I'm sure bad things would happen. But this is G-code. This is something that you take this file, you load it onto the controller for a mill via network, via a flash drive. Now you can actually use flash drives on some of the new machines, and tape on the old machines, which I'm not even going to talk about. But you're ready to basically get started using a machine now. So that's the basics. That's as far as I wanted to get in today's tutorial. That's quite a bit of stuff. That's it for now. All right, thank you.